Good afternoon, everybody. This is a live extreme weather briefing, and I am introducing the red mode. This is extreme red mode for live briefings. This is when big problems are imminent. I'm going to go with this red mode here for the live briefings. You can see a new studio. This is back from our Dominator intercept of the Bottle tornado there in South Dakota back in 2010. I've also got a new mic here, professional microphone. But this is the code red mode. This means that severe weather, impactful severe weather is imminent in the next few days, and I am talking specifically about this Dixie Alley tornado threat that's going to hammer parts of the south central U.S. on Thursday, and it looks like there could even be an outbreak potential. Here is that target area, and I continually shift this target area further west, and I wouldn't be surprised if it ends up eventually going deeper into the Texas piney woods there of East Texas as the system continues to slow down. More of a closed low type of a solution. And usually the evolution of those closed upper lows are difficult for the models to handle. So that's why we've seen some changes here relative to the timing of this event. Now it looks like the best chance for daytime severe weather is going to be here in East Texas, passing into central and southern Louisiana, maybe approaching the Mississippi River by nightfall on Thursday night. And this is going to be a nocturnal outbreak as well, progressing across Mississippi and eventually into Alabama. Many of the models show a convective line by about 7 a.m. on Friday, reaching the Alabama-Georgia border, and then severe weather potential in the Carolina-Piedmont up to the Mid-Atlantic zone that we've identified earlier as an area that often gets tornadoes this time of year, usually Dixie Alley and the Carolina-Piedmont Alley up toward the Mid-Atlantic down to Central Florida has also a mode of similarly varying severe weather. But in this case, you can definitely see where a tornado outbreak potential beginning Thursday afternoon here in the Texas piney woods, maybe down near Houston. You get some of those early storms that develop in late morning. Often you'll get an early tornado down there before the winds veer and before the whole entire system ejects, hammering Louisiana, eventually central and southern Mississippi too. But we are going to break down the models here. And I wouldn't be surprised to see some earlier tornadoes late morning Thursday down into southeastern Texas. But then the afternoon event begins anytime afternoon, and there's likely going to be tornadoes across central and southern Louisiana. I may even end up working the I-20 corridor. There is some model discrepancy right now in the position of the surface low. I saw last night's European model had a stronger surface low back in north central Texas. The GFS had an equally strong surface low, but a little bit more progressive, a bit further north. And the NAM, which actually shows extremely favorable parameters for a tornado outbreak, had a slightly weaker, more modest surface low a little bit further south. So I wouldn't be surprised if the more dynamic solution for the surface low at least verifies for the GFS and the European. That would certainly bring the I-20 corridor into play. Shreveport to Jackson type of a corridor. You could also work the I-10 corridor. Anywhere in between, you're going to be having to make an intercept move to get on to these tornadoes as the road networks, the west to east roads are a little bit less favorable in that zone. These are also going to be fast moving storms too, a very dynamic atmosphere that's in place, and that's what happens during the winter. These tornado outbreaks are driven by kinematics and wind shear with skinny cape but abundant surface-based instability. Basically means you have low cloud bases, you have a buoyant atmosphere all the way down to the surface, and then you get extreme wind shear, and really any convective element rotates and potentially produces tornadoes when that wind shear adds up. So let's first look at the NAM and the progression of the surface low, then we'll compare the different models as well based on that surface low position. It's a Colorado low, develops there in Colorado. It's going to dive way down to the south. There it is. Actually, there's the original low coming out of northern Mexico. We can look at the shape of this system. Strong positive tilt. Basically, you have a parent vortex that's going to shear out and surge across eastern Canada. And then this lobe of vorticity, you could call it a lobe of vorticity, but really it's a bowling ball down there on the southern end. This becomes a dominant storm system. This led to even a supercell structure in Southern California yesterday that passed just to the south of the Anaheim Hills and dumped quite a bit of hail. Dumped a lot of snow in the mountains there of Southern California as well. Began as an atmospheric river event with subtropical fetch in the south side of this trough as it came in. Now it's become a cutoff upper low there. Big bowling ball of cold air aloft, air approaching minus 30 degrees Celsius there, all the way down to, deep into the Baja Peninsula. And this thing's going to cut off across northern Mexico and really mature just at the right time to bring severe weather in Dixie Alley. And I know this part of the country in Louisiana dealt with numerous hurricane landfalls. A couple of those were within about 14 kilometers of each other. Hurricane Laura and Hurricane Delta down there in the Creole Cameron area. But there you can see this cutoff low bottoming out there in northern Mexico, becoming closed. It's not necessarily a cutoff low because it is basically intertwined with this jet stream, a jet stream with a lot of ripples in it, even a little bit of split flow trying to show itself. It's not really an El Nino pattern, it's an El Nino-like pattern for different reasons than if you had those warm tropical anomalies across the tropical Pacific. Right now we've got a La Nina event in the tropical Pacific, so we have cold water temperatures out there, and that's leading to single consolidated jet, open waves that try to traverse across the country. But when you get these waves that are so intense that they cut off down here, this is more of an El Nino-like pattern, and that's because you have an energized subtropical jet with El Ninos. That leads to shear, cyclonic shear vorticity at the base of the trough, causes them to dig, cut off like this, and then can have days of severe weather, heavy rain. You get a lot of heavy rainfall. Not as much in the way of tornadoes because these closed lows like this have a lot less vorticity advection downstream. But then once they eject, like this thing's going to do during the day on Thursday, that's when that vorticity advection really ramps up downstream. And this storm system actually gains a bit of a negative tilt to it upon ejection. Obviously here is a closed low, it's a bit more neutral. A lot of strong flow though downstream of it at the mid levels of the atmosphere. But you can see why there's a lot of forecast model uncertainty with this. You've got a system coming in behind it, barreling down into California, basically just invigorating the flow on the backside of this mean trough dominating the western U.S. As is possible, it could come in as a kicker system, though, and bring some more winter weather to the southern Appalachians. But this bowling ball of a system is trying to gain a negative tilt because of the interaction with this trough back behind it. Basically an effective negative tilt to this slightly closed upper level low. And as this thing slingshots to the northeast toward the Ohio River Valley, it's going to ramp up the vorticity advection downstream. It's going to lead to the formation of a massive low-level jet as well. This is at 21Z on Thursday, so this is at 3 p.m. And look at the axis of this low-level jet in East Texas here. This means that severe weather, an arc of supercells likely producing tornadoes, is going to develop in East Texas, Texas Piney Woods, overspread Louisiana during the late afternoon into the evening hours. And this slower motion of this upper level system could increase the likelihood of a severe weather event to the east of the Appalachians too, across South Carolina, North Carolina, portions of southeastern Georgia too. But this is a big time low level jet, 70 knots there in East Texas. And that's going to lead to tornado potential. Bit of a saturated sounding here right in the middle of a convective line, obviously. That's why you get kind of an inflated. And one thing you want to look at whenever you look at these forecast soundings for these events, you want to see if it's sampling in the middle of convection. And when you get saturation, when the green line is basically the same as the red line, temperature and dew point, when it's about the same all the way up through the mid levels of the atmosphere, that means that that point is sampling a storm, and probably a supercell storm right in the middle there. And that's why I'm really excited too to get the HRRR model to look and see exactly what this convective evolution is going to be. But I guarantee you it's going to be supercell storms, because you've got a boundary that tilts back to the northwest here, and you often get that with these negatively tilted systems. I do think that the NAM is underdoing the strength of this surface low by this time in northeastern Texas, 21Z on Thursday. But look at this convective line in East Texas, and these are going to be supercell storms, likely producing tornadoes. You can maybe get an idea of what the open warm sector looks like by taking a sounding just a little bit to the east. Look at this elevated mix layer, a little dry pocket of air coming in above 3 kilometers, 3 to 5 kilometers out there. That's going to help to steepen those lapse rates a bit. Big time low level jet, that 1 kilometer wind exceeding 60 knots out here in the open warm sector. A lot of backing of these low level winds too. This is actually very similar to the profiles that we saw in eastern North Carolina that didn't quite consolidate into tornadoes. And that's because that storm motion was closer to the due north and south direction. And really any right mover, anything to the right here, any easterly component is going to ramp up that helicity within that hodograph. Looks like my code red here is blocking that hodograph just a little bit. Let me show it to you. There it is. And that's a big sickle-shaped hodograph right there. The surface wind is about 10 knots, so the due southeast 1 kilometer wind in excess of 60 knots. That's about 50 knots of bulk shear between the surface and 1 kilometer. Then you've got the mid-level winds up here, about 70 knots out of the southwest. You have some directional shear as well, going from a south-southeast direction at 1 kilometer to a south-southwest wind at 6 kilometers. It's possible that right mover could be a bit further right than is indicated here by the bunker storm motion. Plenty of moisture at the low levels, upper 60s dew points. A lot of turning in the low levels. These southerlies here are between 700 and about 500 millibars. These southerlies here could drive a more meridional storm motion that could act to mitigate that tornado threat. But really, if you get any backing extending up here a bit more, then you flip around to these southwesterlies, or if these southwesterlies start a little bit lower in the atmosphere, I think that this is a pretty textbook tornado sounding. And anytime you get these negatively tilted troughs with an arc-shaped boundary ejecting like this, you usually realize the right storm motion somewhere within this convective line, whether it be down near I-10 closer to the Gulf with more veered low-level winds, or further north near I-20 where you get those more backed low-level winds. But now let's zoom into the southern plains. This is the incredible pivotalweather.com website for model visualizations. And here you can see that convective line, supercells here, ripping off to the north-northeast. And anytime you get these boundaries that bend back to the northwest like this in northwest Texas, even a north-northeasterly storm motion will be able to move off that boundary cleanly and move into that deeper wind shear. You probably got a warm front that situates along the I-20 corridor, as you can see there. Let's look at some of the instability. And again, CAPE isn't defining characteristic of this pattern, but it can be at least be used to identify how far north that warm front does lift up. And so far, at least, the regular NAM, operational NAM, shows the warm front lifting up to about the Alexandria area. Plenty of surface-based instability down to the south of that. CAPE's approaching 1500 in a surface-based sense. Wrapping around, though, on the north side of this arc, that instability goes all the way into the Texas piney woods. But really, you could click an area on the western side of that blob. You got a PDS, tornado type of a sounding there, and hodograph. Look at that, hodograph dominating. Let me make sure I square this a little bit better. So there you can see that hodograph, pretty much textbook. Anytime you get 40 to 50 knots of bulk shear in the lowest kilometer, you're going to be talking about a tornado sounding and a profile that can really mitigate negatives for tornado production. Can kind of overcome those. This hodograph looks so favorable right here with such extreme low-level wind shear that even if you don't have the perfect storm motion and you have a bit of a shallow critical angle, this will more than compensate for shortcomings with that. You can see a hint of an elevated mix layer here coming in off the Mexican plateau, even though you do have these meridional winds up to the mid-levels of the atmosphere. And notice this, south of the warm front, you get more of a southwesterly motion here at 500 millibars instead of that due southerlies all the way up above 500. And that should bring this storm motion a little bit further right, even though it is dominated here below 5 kilometers by those strong winds at 1, 2, 3 kilometers up. And even so, even with basically a meridional storm motion, you're still going to squeeze out a lot of storm relative helicity here. SRH of 387 meters squared per second squared on this sounding. Plenty of steep lapse rates. You do have a little bit of a warm layer coming in there at 500 millibars as those winds shift over to a southwesterly direction. Warm/moist layer, which could be some kind of a cirrus shield or high-level cloud deck up there, or just some kind of a model artifact. Let's see if it's on here. So, a very interesting setup with that low-level jet. And now let's see where the models differ on the placement of that surface low. And that's going to determine how far north that warm front lifts. The NAM, as I mentioned, has a weaker of the surface lows. With that 997 surface low there. Again, if you're just joining us, we are code red because we have a Dixie Alley tornado threat coming up ahead here on New Year's Eve, which means I'm going to be chasing both Christmas Eve and New Year's Eve for this setup. But there you can see the surface low 997 by the NAM. And let's show you what the GFS does with a bit stronger of a system, but it closes off a little bit later. Well, this is the 12Z. Oh, good heavens me. So the 12Z GFS is in more along the lines of the NAM at 12Z with the more subtle surface low, upper 990s lifting northeast through East Texas. Still waiting on this 12Z NAM, the morning NAM that's coming out. But I was looking at last night's runs. And boy, look at this. The 3 kilometer NAM is slowing it down even more with a 996, 998 millibar low there. But last night's Euro had this diving down to 993, 994, a bit of a stronger surface low. This is probably because the upper level system remains closed through Texas for a longer duration. That means a little bit less positive vorticity of action downstream, less surface pressure falls, and a slightly weaker surface low there. And the 3 kilometer NAM is showing a little bit more of a messy type convection here from eastern Texas into western Louisiana. You'd probably want to target well ahead of this convective line here. Maybe even out over southwestern Mississippi toward the Natchez area near 0Z. But it certainly does look like quite a messy convective evolution here, at least on the high resolution NAM. And that could be because this system remains more of a closed upper level low for a longer duration after it departs northern Mexico. A lot of flow here on the east side too at 500. A lot more in the way of meridional storm motions as well. So now that we're starting to see the 12Z models, it looks like, look at that low level jet eject between 21Z and 0Z. And impinging on southwestern Mississippi there, near the Mississippi River by 0Z. So even though this is moving a bit slower, I still think it looks like Louisiana, central and southern Louisiana, southwestern Mississippi are going to be in the action zone. Let's take a forecast sounding here near Natchez, Mississippi, and that's still a nasty looking hodograph right there. When you get a 1 kilometer wind at 60 knots, surface wind at about 10 knots out of a southeasterly direction. Storm motion is a bit more meridional now, and that's what I've been saying about these trough ejections, is anytime you get a closed low like this, the timing of its evolution, the timing of its ejection can certainly be a little bit different between the models. So we're probably not going to know if this is going to be a major tornado outbreak until it actually is happening. Because the shape of that upper level system is so critical, especially with such a compact upper level low like this, transitioning from a closed low to an ejecting upper level low with an effective negative tilt with it. Let's take a look at the dew points here, and we'll look at wind shear. Look at the energy helicity index, kind of showing that instability axis there by 0Z. And this is a 12Z, 4 kilometer NAM, 3 kilometer NAM. So here you can see the instability going all the way up to I-20, all the way up to Monroe, Louisiana here. Doesn't quite make it all the way up to Shreveport or eastern Texas. So even though I do want to extend that risk area further west, the kinematics do eject off to the east as this system transitions from a closed upper level low to more of a slingshotting wave. And that happens during the day on Thursday, kind of getting this egg shape with that trough axis oriented from northwest to southeast. Back here, where a lot of this flow is unidirectional, is probably going to be less likely to be severe. But off to the east of this jet streak, where you get more southwesterly winds at 500, the mid and upper levels of the atmosphere, is probably going to be just ahead of this jet streak where that convective line is located. So really, anywhere ahead of this convective line, Alexandria down toward Lafayette would be a good area to target. And then you could track it off to the east toward the Mississippi River, maybe end up in the Natchez area. And the 3 kilometer NAM is already hinting at some renegades developing out here near the Mississippi River Valley, near Natchez area. That's always Natchez to Vicksburg is always a good area to target out there. I-20, further south of I-20, southwest of Jackson, out there near the favorable terrain of the Mississippi River. Well, you can certainly see those dew points into the mid-60s, at least from Alexandria off to the south, mid-60s all the way up to I-20. Probably going to require these 66, 67, 68 type dew points from Alexandria off to the south. And this is going to be an event that you want to stay out ahead of it, watch it evolve on the synoptic scale, watch the shape of that upper level storm system, Watch when the winds are going to veer off to the southwest of this event, with the best shear shifting off to the east. Certainly see how these winds are veering, almost like an effective dry line that happens there, ejecting into southwestern Louisiana. All these backed winds, that's where the moisture axis is located. And the latest model trends for the 12Z model show a weaker surface low kind of meandering off to the northeast, and that's not as favorable for a big time outbreak. Yesterday evening, the European was showing a stronger surface low, digging further south, maintaining those stronger shear profiles off to the east. But really with a subtle surface low lifting off to the north, that could allow for more unidirectional winds at 500, which definitely is a failure scenario for this severe weather event. But I think it's going to be in this area, central Louisiana, over towards southwestern Mississippi, definitely in that action zone. And the regular NAM is even a bit slower than the 3-kilometer NAM, interestingly. So this is 10 p.m. Friday night, big time wind shear, big severe weather event, ejecting toward the Mississippi River Valley. Veered winds back behind this convective line. But this thing's going to be approaching the Mississippi River by 9 or 10 p.m. according to this model solution. Natchez down to southeastern Louisiana are going to be in the action zone there for severe weather. There you can see that zone. And it's going to be a nocturnal severe weather event across central and southern Mississippi. There you can see that 0 to 3 kilometer energy helicity index continues there overnight. This is near midnight, probably near the Jackson area where that convective line will be going. This is going to be an all-night type of a storm chase. Broken line of storms here, embedded supercells, mass chaos happening out there across southern Mississippi, south of the I-20 corridor, Jackson, down toward Gulfport and Biloxi, maybe up toward the I-20 corridor, but these models are showing that looks like most of the instability is going to stay I-20 and off to the south. And by 12Z, by Friday morning, continues to slow down that convective line and deep into Alabama by this time. Not a favorable diurnal cycle to get a big tornado outbreak in Alabama, but you still do have conditions that are favorable for tornadoes in Alabama, even by Friday morning. And the models are definitely showing a broken line of supercells in Alabama ongoing by 12Z. That line dies out by later in the morning. And then we get a reinvigoration of the severe weather event during the day on Friday to the east of the Appalachians. There you can see that warm front starting to lift off to the north. That's 21Z on Friday. And this could be a severe weather event that impacts here, right where I'm delivering this live briefing in upstate South Carolina. Maybe more of a central South Carolina, coastal North Carolina type of an event. But the system is ejecting toward the Great Lakes. So largely the low-level jet ejects off to the northeast with it. Kind of a trailing residual low-level jet here across Carolinas into southeastern Georgia. So it looks like this is going to be more of a marginal severe weather event, more of a squall line with unidirectional winds from the surface all the way up to the mid-levels of the atmosphere. That's what it looks like on Friday on the day after. Well, some of the other models are showing. The GFS is showing a stronger residual low-level jet from eastern Georgia through central South Carolina. There is the potential that there could be a tornado threat with that, but really this upper system ejects toward the Great Lakes. It looks like it's happening faster and further west. So I think that the New Year's Day severe weather threat is likely to subside. Look at that. Trash system there. Probably going to bring a lot of rainfall and maybe some snowfall to the southern Appalachians by the end of next weekend. It definitely looks like a heavy rainmaker with that strong positive tilt there. General isotropic lift off to the east of that trough. And things get a little less exciting after that for a while, but there are some indications that potential for East Coast snowstorms could increase with some big time blocking happening over Greenland. Big negative NAO type of a pattern, one that we haven't seen in a long time. Probably put in motion by this pattern shift here. But look at this bulbous system lifting off to the northeast quite rapidly, and a lot of that happens because of the kicker system back behind it diving off to the south. If this system was able to surge across Dixie Alley, you'd probably be talking about a bigger outbreak. But still, this slingshotting motion to the northeast leads to the formation of a dramatic low-level jet. And that's why this has the potential to be an outbreak of tornadoes. Anytime you see these low-level jets cover multiple states like this, beginning here in central, southern Louisiana, and then pushing off to the east, consolidated 850 low like this. Bit of a negative tilt with this trough, but it's a very compact system. Still a lot of uncertainty associated with the ejection of this trough. See how the NAM has it just a little bit more closed. But there's quite a bit of agreement within these models here. The evolution of that upper system. European is a little bit slower with the ejection, has the weakest surface low. But really the pivot to this northwest to southeast oriented tilt and the resulting vorticity ejection downstream of it is key to get the formation of a pretty robust surface low down there in East Texas. So it looks like we do have a lot of uncertainty still with the models. Still got to keep breaking these down. But I did paint an area here in Dixie Alley that includes Louisiana, central and southern Mississippi for the potential of a tornado outbreak. And of course I am going to keep a very close eye on this. Likely will chase this additionally. I have the Varsity Tutors live stream tomorrow afternoon. Likely be leaving after that to target this area in Louisiana. As long as it doesn't fall apart a little bit more, there is a chance that it could be kind of a messy outcome. But anytime you get a 60-knot low-level jet that's so robust and ejecting like this, usually it's going to be at least a regional tornado outbreak, Louisiana and Mississippi. So thank you guys for tuning in to my weather reports. Hope you enjoy the different look here with the Code Red theme. Let me know in the comments if you think that I should continue with it. But just wanted to thank you guys for tuning in to my weather reports. I am working on this makeshift studio here with some old tornado artwork back behind me. This is a photo that I gave to my mom for the holidays a while back. There you can see the Dominator with the air cannons. Big bottle tornado with a collar cloud on the backside. That's our air cannon system that connects to the compressed air. The air compressor in the back of Dominator 2, and that was capable of launching those projectiles and probes with a parachute attached into these tornadoes. The issue, though, was getting trackable sensors back then, and thankfully we met Mark, or Chase and Spin, on Twitter, and he's made it possible for us to track these sensors and actually launch sensors into tornadoes and get them back and collect valuable data. I am working on that publication for the rocket paper as we speak. Should have that done in a couple of weeks. But more chasing coming up here in a couple days. Thank you, everybody. Have a great rest of your Tuesday. Never stop chasing.